for the first time really in motorsport, all of the research has now been shared publicly. The code is then all open source, so it's on GitHub. It's like a rising tide for all boats.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Dave Finch. Today we're talking all about an incubator and the ultimate proving grounds for open source artificial intelligence in automotive applications. During our Industry Tech Days this past September, I got to chat with Lucas di Grassi, CEO of Roborace and International Formula E driving champion, and Bryn Balcombe, Roborace's Chief Strategy Officer. Check out their perspective on how autonomous electric racing pushes the innovation of artificial intelligence, electric vehicles, vision systems, and lots more in the automotive field. It's really cool. Hello, everyone, and welcome back to the first ever Industry Tech Days presented by All About Circuits. I'm Dave Finch, host of Moore's Lobby, the podcast by engineers for engineers. Today is Wednesday, September 2nd, and we are kicking off day 3 of what has been a refreshingly useful conference so far. I got to say, editorializing here, this event is blowing my mind, and we're not even halfway through the week yet. On Monday, we spoke with the founder of FreeRTOS about edge computing and the Internet of Things, specifically the realities facing engineers in these designs. And then yesterday, we had the MIT electrical engineering professor and CEO of edX, Anant Agarwal, took us all to school on the topic of online learning and its massive importance to the engineering community. And today, well, buckle up. We are kicking off day 3, very much like a Formula E qualifying round, fast and electric. Let's see. I'm just going to advance. Our keynote speakers today are none other than world champion Formula E driver and Audi Sport and Roborace board member Lucas di Grassi and Roborace's Chief Strategy Officer Bryn Balcombe. All right, let's dive in here, guys. Welcome to the show. Thanks for joining us.
Thanks, Dave. Pleasure being here. Really excited to talk about racing cars, electric, and an autonomous future.
Absolutely.
Yeah, likewise. Thanks very much, Dave.
Yeah, it's really an honor to have you. So let's dive in. When it comes to automotive electronics and innovation, the current electronics industry media, in my opinion, seems to love nothing more than hyping a few topics that have become almost like crutches. These would be 5G technology, autonomous vehicles, sensor fusion, and artificial intelligence. And a lot of writers get it totally right, and it's really great content. But I feel like when a tech journalist is having a rough week, he or she can just pen a quick article on any one of these topics and feel as though they're making some kind of contribution. And I'm never convinced that it even means anything to the engineers that they claim to be writing for. So for like more than a year now, probably, I've basically ignored these types of stories when they show up in my feeds. And then along comes Roborace. Easily one of the most exciting, if not the most exciting endeavors gaining traction in automotive today, in my opinion. From an engineering standpoint, it's real, it's grounded, it's here and now research and development that is going to accelerate the viability of things like AI, advanced sensors, 5G connectivity, and even things like next generation battery technologies in automotive applications. Clearly the work that you're doing right now has massive implications to the consumer automotive electronics industry. And this is what people should be paying attention to. So, Lucas, until recently, you were CEO of Roborace. And I was hoping you could start us off today by explaining what Roborace is.
Dave, I'm a racing driver. My dream when I was a kid was to drive fast cars, but very quickly I saw that the automotive, the motorsport, actually serves as a R&D, as a research and development platform for commercial vehicles, and nothing comes more to my mind as a future endeavor than having driverless vehicles, electric, going safe, fast, and cheap around cities. So when the founder of Roborace, Dennis Verdlov, invited me to be part of the series at the very, very beginning, to help to develop the car, to help to be more as an advisor, I was very pleased, very honored. I joined Roborace in more or less beginning of 2016. And then I was following the roots of Roborace together with Bryn also. And then in 2017, Danny said, look, Lucas, why don't you join as CEO? I will be running the company very close to you and helping you to make this series become whatever you and Bryn decides in terms of a strategy of the future. How do you think is the best way to attract talents, to make it worldwide known, and to accelerate? So the base of Roborace is to have a top-down approach to accelerate the technology around driverless vehicles, is to find that ultimate algorithm that will be faster than any driver at any conditions, anywhere, and then scale to commercial vehicles, and then use that also because it's a racing series, because it's exciting, to use that as a promotion, as the same way as we did with Formula E, to change people's perception of how good the autonomous vehicles can be. So if you see cars going at 300 kilometers per hour, inches or centimeters from each other, with a very, very high precision, and doing it better than humans, I also believe that the acceptance of society will be much better for autonomous vehicles. So you have the R&D and perception are the two key elements that why Roborace exists. In the same way as F1 has done in the past, accelerating safety and other technologies, the future is autonomous. So we have to develop the safety, the R&D aspect, and the perspective of the society towards an autonomous future.
Hey everybody, it's Dave. This portion of Moore's Lobby is brought to you by AVX, a leading provider of advanced electronic components, interconnect, sensing, control, and antenna solutions. AVX is proud to sponsor Geox Dragon Racing in the Formula E All-Electric Racing Series. AVX offers automotive EV and HEV component solutions for powertrain, active body control, ADAS, lighting, and power conversion and drive control, all manufactured to the highest quality and reliability standards. Their long track record and more than 30 years of experience in automotive products enable customers to rely on AVX as the one-stop source for passive components needs. For more information, visit avx.com/formula-e. I'm curious about the allure of Roborace to a professional driver such as yourself, because on the surface, it might appear that you're effectively designing yourself out of the car, but there's probably more to it than that. Yes,
my colleagues, normally they say I'm a turkey cheering for Thanksgiving Day, because you're gonna make us all unemployed. And I'm like, look, autonomous cars, we're gonna make us all of us unemployed anyway. But if we manage to accept it, develop together with motorsport, maybe we can use this instead of just like saying, no, I'm not gonna look like in the, let's say, 90s. I'm not gonna look in the online commerce. This is something else, or Kodak. I'm not gonna look into digital film. And then a few years later, you're dead. What I'm trying to do is first use my knowledge and my expertise that I helped create Formula E, and try to find a transition way to Roborace to become a worldwide known series. but also try to implement in a very specific way that we can separate the technology that is important for autonomous vehicles and really focus that into Roborace and leave the other side of motorsport very human-centered. The analogy that I use is that it's not because Deep Blue, the supercomputer from IBM, beat Kasparov in chess in the 90s that people don't play chess anymore. Nowadays, right. Even any app, you can, if you want to play chess against any app, there is a almost like 100% chance you're going to lose if you try to play even in a phone nowadays. Sure. But people still play chess against each other. You want to see who's the best player. And I think with motorsport, it's going to definitely happen something like this. People still want to see which is the best driver, the most skilled, the most brave, the ones that can drive the best car in the worst conditions. But eventually, the computer will be better than any driver. And then I dream at one future that even you can combine both. I could imagine the 24-hour of Le Mans, an endurance racing, or the most extreme endurance race in the planet, that you could do one stint, so one part of the race purely autonomous, and the second part a driver. So it's a combination for the manufacturer of a driver driving one part of the race and the computer driving another part of the race. And for the amateurs, having an AI assistant, so having an AI coach that can help the driver to achieve its limits in a safe way. And even for supercars of the future, it will, when you buy a supercar, it will come, I hope, with a Roborace based algorithm or AI that can help you to have fun with your supercar and at the same time being in a safe side. So that's how I see it, and that's why we did season alpha, which is what we're calling it the first season that we did last year with Roborace with the competition, and then calling it this season, which was kind of changed because of the COVID situation and all the problems we had, but it's still happening. Season beta before we go to season 1, which will be let's say next year or a second semester of next year, to really have the teams competing in a very high level. We are talking about only now around 3% lap time. I even have a bet against the owner of Roborace, against Dennis, that we're going to actually try in October now. That is always we do it every 6 months, me against the car. So to see how the algorithm is evolving. Wow. So it started about 18 to 20% slower, which is pretty slow, but now it's only 3%, and that was like a year ago. So I'm really looking forward to see. We called it a singularity when the AI is able to beat a professional racing driver.
Yes, absolutely. I'd weigh in on that bet.
It's just a matter of time. It's just a matter of time.
That is fantastic. And you know, what I love about what you're saying too here is it can be man and machine. It doesn't have to be either or. They're not mutually exclusive. And the advancements, when you solve problems for autonomous vehicles, you're solving problems for all mankind. You're solving problems for all of us. Every car will improve when we can, like you said, achieve a car that will drive 200 miles an hour, inches apart from each other, safely, no crashes. It's all upside, in my opinion. Yes,
there was actually a study in the US. The cost will go down. So it'll be a democratic way of creating much better mobility. There are two aspects. First aspect is when you take a taxi, about half of the cost is the driver, even a little bit more. Depends on how you go. In the US, it's even more. In a developing country, it's a bit less, but depends. But around 2/3 of the cost of when you take a Uber or a taxi is the driver. So when you take the driver out of the equation, it becomes very, very cheap. You cannot compete only with hardware. So that's why there is this race towards automation, because everybody wants to be the first one, and the first one gets more data, is exponential growth. So the first one dominates the market, dominates mobility. It gets cheaper. Second, when you buy a car today, when the average American buy the car today, 95% of the time the car stays still somewhere, parked somewhere, either at your home, either at work. So it costs real estate space. It costs you, it's a depreciating asset that you put a lot of money. Actually, normally cars are the second biggest expenditure a normal person has after their house is the car. So it's a depreciating asset that now you're buying it. It stays 95% of the time parked, depreciating value with time. It's not going to be like this anymore. You're going to ask for you need to go somewhere. You request an autonomous car. It picks you up and drives you somewhere and then picks somebody else up. So you're going to be driving. So we're going to be a much more smart way of using the resources, using the materials, using everything that is needed to compose a vehicle. That's why the race is so important. And that's why even if we are in early terms with early in a way, there is already autonomous cars, but in level 5 massification of usage that you go from your farm to your to the door of somebody in another city, or you go in a car and you sleep and you wake up in another state or in another country. Right. This is a bit far away, but the first steps of automation, which are closed lines of buses, which are airports, which are any kind of already predetermined route inside a city, this is already existing and this is already there. And everybody's having a bottom-up approach. So everybody starts with very slow cars, trying to figure out what to do. Tesla, of course, has their approach with computer vision and collecting massive amount of data. We decided with Roborace, let's start. So what's the most difficult thing for a driver is to drive in a racetrack. Let's start from what is the most difficult and then bring it down to the commercial vehicle.
Absolutely. It all sounds so awesome to me. And while we're talking about technology advancements and all the things that that have to come together for this to be a reality, Bryn, why is the electric vehicle powertrain suddenly getting so much attention nowadays?
Yeah, I think obviously Lucas is kind of more of an expert in this area than me. So yes, within Roborace, we use a fully electric powertrain. For cities around the world, clean air, and Lucas is a UN ambassador. In that regard, it's incredibly important. I think the number of lives lost just through clean air is substantial, Lucas, every year, if I'm correct.
Yes, so, about 4 million a year people, according to the UN report. Yes.
Oh my gosh.
So just for clean air in cities, I think that becomes really important. And then there are obviously then the benefits that lead towards CO2 emissions, depending on where you're sourcing your electricity from in the first place. And I think that's always the big question, is where you get your electricity from. But in terms of like sport and performance and competition, the key thing that we have with the robocar is we have a unique ability now with electric powertrain to have 4 independent electric motors within the vehicle. So, if you look at Formula One, even if you look at Formula E, which is fully electric, there's only one motor. And then you have to you have a differential to distribute that power. With Roborace, you can control the power at each wheel at any moment in time. So the level of vehicle dynamics control that you have is significantly higher. And so the performance you get from that, or really in the future, the safety enhancements that you get from that is really important. And I think it's certainly a position I know Lucas has been advocating on for Gen 3 Formula E, is kind of to push in that direction of having multiple motors on the vehicle.
It reminds me, and correct me if I'm wrong, because I'm interviewing 2 people in racing, and I should know this, but I'm not sure that I if I remember correctly, Audi was the company that came along and introduced all-wheel drive on the racetrack, completely revolutionized. Is that correct?
That's correct. Yes.
Yeah.
In rally. Yeah.
In rally. Okay. So, and now we're talking about an individual motor on each wheel, not just all-wheel drive. And this is exactly the kind of technological advancement that you're talking about, a rising tide, so to speak, that's lifting all ships. Is it fair to say that Roborace is an incubator for emerging technologies such as this?
Yeah, I mean, that's exactly why our founder, Dennis, sort of set it up, is to look at how you use motorsport to advance that technology. And you you have to have that competitive element, in order to push the boundaries of technology. And then how you structure the rules and regulations are the things that shape how that technology evolves and how it improves. So, we definitely talk about, low-level torque vectoring is one of the things. Obviously, the compute and the sensors that go into the vehicle is another layer. And then above that is the software that's connecting to those sensors and processing and doing the driving. So those three areas will really define your ultimate performance of your vehicle platform.
Absolutely. And it strikes me, Bryn, that we haven't seen a true automotive evolution since the early days of combustion engines. So maybe like 100 years. And now we've got three major catalysts for true evolution in this industry: artificial intelligence and the associated hardware, vehicle electrification across the board, and thriving open source ecosystems. Of these three catalysts, where do both of you see the greatest bottleneck or barriers to progress?
Yeah, I'm not sure if there are, let's say, barrier progress. I think all of those are enablers, really. So the open source community, especially around, let's say, robotics, and in the future, if we look back on this, Dave, in the future, you could just look at automotive as being a vertical within robotics. Robotics is actually the larger domain that will use all of these technologies. Autonomous vehicles are just one subset of the type of robots that we're going to be experiencing. And so there are some great open source robotic frameworks that are out there. And certainly some of the teams that compete within Roborace are already utilizing those, just to speed up their development process, for example. So I think there's actually a lot more enablers now, even compared to 4 years ago when we launched. There's a lot more that's existing now that can accelerate these technologies.
Mm-hmm. And how about the rest of the vehicle? For instance, batteries. It seems like the battery is something that has been evolving, and maybe is there kind of a catch up period that we're experiencing with battery technology right now, or are we approaching revolutionary new technologies where you can complete an entire race and not have to worry about charge and that sort of thing?
I think this is definitely Lucas's technology.
I was gonna say for me, we're talking about bottlenecks or constraints in development, and for me, the battery is the biggest of all. It's actually not battery per se; it's actually energy storage and energy deployment, which in this case, electrical power needs to be stored somehow in a battery or a supercapacitor or something like this. So for me, batteries are evolving quite slowly. There is a lot of investment. There is a lot of companies around with solid state solutions, with lithium air, with other solutions coming along, with graphene batteries. But this is, for me, the biggest constraint. But there has been some good evolution, especially in the pricing of battery, because for everything that we're talking about, from AI, processing power, 5G, electrification, to be massified as a commercial product, you need to have the right price point. And that's why we have this convergence. We've seen the price of battery coming down. We've seen the processing power going up. We see the connectivity going up, so you have more data available, with better sensors, you can process it better, artificial intelligence, machine learning gets better, and then it can deploy in a much better way into an electric powertrain, which is basically electric motor and the battery. And Formula E was a perfect example of it. When Formula E was created, I was very, very much involved in the creation of Formula E since the very beginning. I was employee number 3 of Formula E, and I saw the evolution of the series. We had to go with 2 cars per race. So we needed to do a 45, 50-minute race for TV, but there was not enough. It was impossible with the performance requirements to do everything with a single car. So we decided to do, for the first time in motorsport, a race which the driver, instead of in the pit stop, change the tires and refuel, the driver would jump out of the car, go to the car B, let's say, jump out of car A, go to car B, and then go again after half of the race. And in only 4 seasons, so 4 years, we managed to double the energy capacity in the battery and go to a single car. So today we have about 25 to 30% more power, more performance, and a single car and a single battery. So if it continues to evolve like this, I hope in the next decade or so, we're going to have equivalency of energy storage between fuel and batteries. And then we're going to have flying cars, planes, helicopters, everything that has a medium apart from rockets, because you cannot build an electric rocket, that is by the laws of physics. Apart from rockets, you could go, everything could go electric and become much cheaper. So imagine a car that now weighs, let's say, 2 tons. 1 ton is more or less the battery, almost 40%, half of the weight of the vehicle is battery. Imagine if this battery reduces by 10-fold, then the cars would be even cheaper, more powerful, better, more clean for the environment, and so on.
Hey, it's Dave again. This segment is brought to you by Rome. Silicon carbide pioneer Rome Semiconductor is now sampling its new 4th generation of silicon carbide MOSFETs that utilize an improved trench structure to deliver the industry's lowest on resistance without sacrificing short-circuit withstand time, while low switching loss is achieved by significantly reducing parasitic capacitance. This expanded lineup includes a 4-pin TO247 package with an extended Kelvin source pin, a 7-pin D2-pack surface mount package, a 7-pin D2-pack surface mount package, and new SDIP power module. Be first in line for samples today at rome.com/SIC. When you look at the differences, the pit stop, I love that. I love that because, what I have in mind are the team that descends on the car, and in less than a few seconds, they're back on the track, and that's tires, fuel, everything. Are there other differences in the race itself that people might not realize? Differences that are being introduced by autonomous racing or even Formula E, such as are they quicker lap times? Are they tighter lap times? In Formula E, I think the main difference to conventional motorsport is that because we started only 6 years ago, we could come up with a technical regulation which was very cost efficient. And when you say that, what does it really mean? It means that the manufacturers involved, they will get a lot of R&D done in racing, then transferred to the commercial vehicle, which was lacking in other sides of motorsport. And Formula E kind of got this niche of electric powertrains, and with the regulations, the motors are evolving, the inverters, everything is evolving. But there was still a niche on motorsport to go for autonomous technologies, and that's why Roborace kind of filled this gap. So with Formula E, you're developing the powertrains. With Roborace, we look at standard powertrains for everybody, so everybody has access to the same motors, same battery. This is not to be developed, otherwise you're focused on the wrong things. And now competition is based on software. So the competition of Roborace is based on, each competition is different. It's not a traditional race. So you have different formats of racing. You have different ways of doing the competition, even with augmented reality. With you can do anything. You can go really crazy. You could eventually, for example, you can put on the racetrack virtual people, trucks, and cars, and the racing car has to go around them and complete the lap time in the best time possible. So it's not only the fact of going around the racetrack, which might not be very commercially relevant, but with augmented reality, with the software, we can actually come up with any kind of challenge that in the end will have a commercial impact for the people involved. Absolutely. And I like the way that you put that just now, that the competition comes down to the software and the algorithms. So, Bryn, sitting in your seat as chief strategy officer.
This is Bryn's domain. So if you're going to ask something about software, please go to Bryn now. Don't. That's actually very good.
All right, cool. We will. I will. I've actually got a lot of questions about this. So Lucas, you can put your feet up and enjoy the next few minutes. Bryn, this is one of the things that fascinates me about the business model of Roborace is that you are competing on the algorithms and then taking what we're learning and developing and making that available to to a mass user audience, to engineers everywhere in the open source communities. And can you tell me a little bit about that?
Well, I think it's what's very unique about Roborace, actually, in comparison to any motorsport that, either me or Lucas have worked in. I've been in Formula One, Lucas has been in Formula One, and everything is a guarded secret. Everything that improves performance is kind of hidden away and you don't talk about it. So it's very opaque, even for engineers to kind of work out what's going on. What we're actually doing in Roborace is we provide the platform. The teams are the ones that then bring the AI algorithms. So, I like to say they arrive and drive. It's like plugging a USB stick in and then you can drive the car. It's not as simple as that, but that's kind of the aim. Normally it's a Docker image for those that care. And what we're able to do then is that through our university partners, any software that they're developing, they want to write research papers about. They want to make it public. So for the first time really in motorsport, all of the research that, say, Technical University of Munich have done has now been shared publicly. So you can go on and read. I think there's about 19 different papers. They have about 7 PhD students working on the project. And all of that information is shared. The code is then all open source, so it's on GitHub. And it's a great, I think you mentioned it, it's like rising tides for all boats. That's kind of the approach that we're taking. The more information that's out there, that's shared, the more you can build upon that. Yeah. And that's really what the open source community gives you, is that ability for people to say, okay, well, I'll take that bit and I'll integrate that, but I'll focus on development of something separate. But we also did some fantastic research with the VW group. So particularly with VW Data Lab in Munich, which is their AI specialist group, and with Ital Design in Italy. And they were using the Roborace platform to do, let's say, research on AI algorithms. And the reason they were able to do that is because we provide that platform that's very easily accessible. And then you can just swap out different modules depending on which area of focus you want. So there was some work that was done on low-level torque vectoring. They could run their algorithms when they didn't want to run that. If they found a problem with that, they could run our torque vectoring algorithm. So it's very modular in the way that you can combine things together from different people, and that really improves the rate that you can develop. So, previously when we first started at Roborace, we went through all of this pain, of developing both the vehicle from scratch and the software architecture from scratch, and everything was kind of, if one part failed, whether it was software or physical, you can't test, you can't move forward. And very quickly we moved to that sort of modular architecture, whereas actually, you can go back to the previous version and continue developing your other areas. So one team of developers then goes off, tries to fix their problem, but it doesn't impact everybody else. And I think that's really important with the architecture you choose.
Yeah, and the architecture is so key. And the architecture also, the business model, I should say, reveals a lot about the priorities of the organization. So everything being proprietary, your priority is monetize, and keep all the patents, right?
Yeah.
What I'm picking up just in this conversation with both of you is that the motivation at Roborace is really to improve the world. And you can say that in a mission statement, but it's another thing to take key learnings from something as rigorous as racing technology development, and then just publish them and allow them, free license. How can engineers access the Roborace platform if they want to adopt the technology and evaluate certain modules?
Yeah, so the key things that we develop, I think so I mentioned it earlier, technology, talent, and trust. They're the three key areas that we're advancing. That's Dennis's aim, is to develop technology, talent, and the trust in the public. To build the trust, you need public engagement. So, Roborace's core focus is how do we build that public engagement? And that's what motorsport gives you, is a competition and a conduit to that. When you start to then look at the software and where the software is available, as I mentioned, a number of our university partners have already published all of their code. If you look at Technical University of Munich and some of their research papers, if you go to their GitHub, you'll find it all on there. When teams join Roborace, we then have an internal set of code that we're able to offer to them, which gives them a starting point. That's shared privately with the teams, but then they can build their own frameworks on the top of that.
Okay, this is so great. One more for Bryn here, and then trying to go back and forth. What sensor technologies, you mentioned the technologies that are being sort of incorporated and integrated. What sensor technologies have been developed, and how have teams been developing these techniques for sensor fusion and image processing and that sort of thing?
Yeah, so on the base vehicle, obviously it's a motorsport vehicle, so there's a lot more instrumentation on the suspensions and the tires and the temperatures, pressures, and things like that come in the motorsport domain. So that's a great foundation for vehicle dynamics and that information. Above that, you then have, we run a GNSS IMU system within the vehicle. So that gives you positioning down to 1 centimeter when we're running in its most accurate mode. But it also gives you the 6 degrees of freedom, movement of the vehicle platform itself. So again, normally they're devices that are too big to run in motorsport, but within our domain, we can run them within Roborace. So you're getting highly accurate positioning data that can really serve as a good ground truth as to where the other objects are. So we have vehicle-to-vehicle communications. We're able to share positioning information. So we can actually run competitions that don't rely on perception at all. We can just use shared positioning information, and the vehicles will avoid each other naturally, effectively. The level above that, Dave, that you're mentioning with the sensors, normally people then start to think about perception sensors, and that's a separate part of the software stack. Within Roborace, we run radar, LiDAR, machine vision cameras, sonar sensors as well, ultrasonic sensors. And it's a combination of them that you really need to bring together to work in all different domains. So if you're racing in somewhere like Silverstone in the UK, which is a very wide open space, it's an old airfield, the GPS inertial system will work fantastically well there. And you'll struggle to find localization accuracy that's better than that using the other sensors.
Right.
If you go to somewhere like Goodwood Festival of Speed, where we've done demonstrations for the last 2 years with Robocar and with DevBot, you'll find that you have huge tree canopies, like tunnels that are made out of trees. And so your GNSS system just does not work in that environment. Right. So you have to rely upon your other sensors. And that's really where your LiDAR sensors come in to give you localization accuracy, where your cameras come in to help you build the map and do segmentation between the track and the grass. So you know where the tarmac is, where you should be staying. So it's a real combination of all the sensors that you're bringing to life, basically. And that's where the sensor fusion becomes most valuable.
Right. And just something in Goodwood, the first year that we did it, which was 2018, we were nowhere. The car went kind of wobbly around and went up the hill. It was the first ever hill climb autonomously. It was pretty good. But 2019, so last year, the car finished position 44 of all competitors. And it had a massive improvement, and not using GPS-based localization, which is at the moment was key to the performance. So we had a lot of margin. So the performance of the car got like really big steps from one year to another. So I'm a bit afraid of the competition, and I'm going to do this year with the car.
Yeah, that was about 14 seconds quicker 1 year to the next. And that was not hardware related. That's all software related. That was the improvements that were made. It's just the confidence that you have in the localization, the confidence you have in your friction estimate, and all of that. It is confidence, and it's interesting because you use those words and it relates directly to human drivers. How much confidence do you have in the car and the feel of the car, and how much can you push the car? Is exactly the same, really, in the autonomous vehicle domain.
Absolutely, and that's this rapid evolution. I mean, at 14 seconds. In any kind of formula type setting, I mean, it feels like a lifetime. And
14 seconds in a long track is a lot. In Goodwood, I think it's like 40 seconds or something like that.
Yeah, exactly. It's a 40-second hill.
Huge. It's like 30%.
Yeah, it's massive.
Quicker. It was massive. You could
1 year over the next. And to get there, you mentioned a lot of this was a kind of the success of some software developments, but across the board, obviously, this all counts as a very rugged environment for electronics, automotive. What can you tell us about how these autonomous vehicles, electrical vehicles, are dealing with shock, vibration, debris, temperature, that sort of thing?
I was going to say not very well in some instances. So it's actually quite a lot of the reliability issues that you have are really to do with the ruggedization of certain components. And so things like network switching, is obviously common in the consumer domain, in the normal office domain. But for automotive, they're not that common. So bringing all of that technology together, making sure that it's hardened, is really important. With LiDAR sensors, we've experienced some issue with LiDAR sensors. But again, where we mount the LiDARs on a race car, they're very low down to the floor on the front wing, effectively, of the vehicle. And when that hits a curb or when that hits the floor, the shock that goes through is significant. So even in comparison to a normal road-going vehicle, you don't have the luxury of the nice soft suspension system where everything's mounted. You actually want to keep the platform as rigid as possible. So we've definitely noticed that motorsport is pushing the boundaries of some of these technologies beyond where they are currently with the automotive domain.
Sure.
And I would also say a lot of the technology is still, we don't have mass deployment of fully autonomous vehicles, which actually means that some of the core components in those systems aren't, let's say, they're not, say, production grade. They're not automotive grade yet. It's research, it's development, it's prototyping, it's demonstrator vehicles. It's not at that level where the components themselves have been hardened for this type of environment. That's improving all the time, and we've definitely noticed that. In the last 4 years, it's improved, but there's still some way to go. And it's the same with temperatures as well. Temperatures are a massive issue, always a massive issue. Kind of often overlooked.
I was gonna compliment it so people have a little bit of a reference of how complicated the process of reliability is in those systems. Is imagine in a road car, normal, you never go over 1G. 1G of acceleration is pretty much the limit. In a, let's say, a fighter airplane, you go up to maybe 10G, 10 times. When we test components for a racing car, we test them up to 50G. If you think about 15G, you get unconscious, and we test them up to peaks of 40 to 50G, the electronic components, because of the high vibrations, the high impact of curbs, the low suspension travel. They need to be reliable for a much harder environment than others. So LiDARs, for example, solid state LiDARs was like a holy grail of autonomous vehicles for a long time, and the moving LiDARs we had, they are all breaking down because they were automotive grade but not racing grade. So they were made for 1G, maybe 2G, maybe we tested at 5, but not at 7, 8, or 10. So they kind of sooner or later they break down. So we had a lot of problems with that as well.
Yeah.
I think it's interesting. I think there was some Formula One recently that had some issues with tires, but certainly there's been cases in the past where you have drivers that are picking up vibrations that are coming through the tires, and it hits a resonant frequency that matches with their eyes, and it means that they can't see as well. They get actually blurry vision. So we've not found that yet within the sensor domain that we're working on, but for sure it's going to exist. Anytime you have something that can move, you're going to end up finding a resonant frequency at some point.
Yeah, exactly. And then, and it's time to bring in the mechanical engineers, and is there something else we can do to dampen this? And the other thing that strikes me is when I think about like an NVIDIA GPU or some kind of, really high power AI engine, I don't think of those as being placed in certainly an automotive setting, let alone, the demands of motorsports.
Yeah, I mean, the original work, as you say, the GPU has become not just a gaming computer device. A lot of the algorithms and acceleration of algorithms is all based upon GPUs, normally sitting in people's workstations, researchers' workstations underneath their desks. So the first way to bring those to life is to take the workstation and put it into the car. And that was really the first generation of all these autonomous vehicle systems were, grab the workstation because that's where the algorithms are, stick them in the vehicle. What NVIDIA realized very quickly is that doesn't work. There's huge reliability issues around that. And so they've taken the core chips and they've created automotive grade compute platforms. So yes, the underlying technology is the same, let's say, but what they're creating now is something specific for automotive. And actually there's very specific processing cores on there that are, again, automotive specific. So it's been great to see that. And now, really, Dave, they're looking towards making that, functionally safe, moving up the sort of ASIL D, up towards ASIL D on functional safety. That's their target. And you need that, really. You need, in some ways you have to think about it like the compute inside the vehicle is like a data center. It needs to meet certain standards effectively, because you're going to run everything else on the top of it. And really, NVIDIA are making that foundation, creating that foundation for everybody else to run on top of. Hence the announcement they made with Mercedes not so long ago, and that's for their new compute platform coming out 2024, I think it is. Yeah,
I mean, you're not only generating, you're processing so much data, and you're processing it with very high stakes. This isn't, I got the blue screen of death. What an inconvenience. This is, going careening off into another car or something. You're doing so much real-time processing that, this really is the upper limit of what's achievable with electronics. I know that when I'm trying to do too many things too quickly on, my workstation computer, I can cause the thing to sort of hiccup and get confused. And it's really remarkable.
It serves the same for 5G technology. You need to have the connectivity between cars. It cannot say just like there is no signal here, I'm going to do something else. Of course it can, but on the safety side, the communication is very important. So also serves the same example. It's not an inconvenience if you have a cloud-based map update that stops in the middle of the run, or somebody can hack your car and drive it somewhere else. So it needs to be bulletproof. We're talking about, of course, human lives. And from society aspect, it cannot only be better than a human. If it's better than a human but has accidents, people will point the fingers at this and that. Even if it's already statistically better than a human, people will not accept it. It needs to be almost fail-proof to be fully accepted. The other day, I read a headline which was autonomous car involved in crash. And I look at the article and I start reading it. And basically a driver missed the red light, crashed into another car, run over another, like a part of the road, and hit an autonomous car which was standing still. And the headline was the autonomous car got involved in a crash. I mean, but this is the perception. So it needs to be developed in a way that is bulletproof. That's why it will take longer than expected. And that's why there's so many critics about Tesla, how they're doing. By the way, they are developing their own hardware to process a large amount of image, because their autonomous is based on purely computer vision. They want to do it without LiDARs to make it cheaper and use more of their already existing data. And I think they will succeed, because in the end, a human is nothing more than also stereo vision processing. We don't have lidars, and we're still capable of driving. So I think it's just a matter of evolving the technology to the right amount, and that's the underlying physics of what Elon Musk wants to do. Humans, they have this, and that's it.
I think that's one of the key points, Dave, actually. Lucas mentioned, we do have two eyes, and that's incredibly limiting. But what that means is that our brains have become very, very good at prediction using very small amounts of information. So you can look down like on a junction, you can see the car and then predict where that car is going to be. And you don't need to look at it anymore because you can accurately predict. It's like at the moment, there's a hell of a lot of reliance still on having 360-degree perception, but it's real-time perception. It's kind of like if you were a driver, you're doing this all the time. You're constantly looking around, but you're not doing the prediction. And the prediction is the thing that you need in order to plan and navigate in the future. And that's really what driving is all about. And in motorsport, predicting how your competitor is going to work in an open road environment. There are rules, but the rules are very limited. Being able to then influence their behavior by your actions is the essence of racing. And that exists on the road. It exists, if you're going into a roundabout in Europe, or it exists going onto a freeway, slip roads on and off of freeways. All of that is a competitive environment where you need to be looking and predicting and then controlling other people's behavior by your actions. And motorsport is the ultimate, development area for that type of technology. And that's what we're beginning to see now.
Absolutely. You're doing things instinctually. And that's why I like that we have professional, not just professional drivers, but, world champion drivers participating in this, because as we know, artificial intelligence, the algorithms are only going to be as successful as the people developing it. They will have biases because humans only have so much experience, and we're all doing the best we can. We can hardly raise our own kids, right? Most of us, let alone take care of something like teaching technology. So there will be something of a natural selection, an evolution of these types of algorithms, of this AI. And what's your take on sort of the natural selectivity of these algorithms? Improving them, who has a leg up, who has the best localization techniques, that sort of thing.
Before Bryn actually answering the question on a more technical basis, I slightly disagree with the point that the algorithm will be as good as the drivers using as a reference. I think if we manage to be successful enough and we manage to be good enough, the machine learning will be so good that will come up with driving strategies that humans cannot predict. The same as with, let's say, the AlphaGo example with the British company behind it. I forgot the name now.
DeepMind.
DeepMind, correct.
Yeah.
So the same as AlphaGo, that the just by machine learning, with nobody having any experience on the game of Go, the algorithm just managed to beat the god of the game, which was this Korean 4-4-1, and come up with strategies that humans never thought was possible before. Yeah. And I think on a strategy level in driving, it could come a completely different strategy. So I could imagine in the future that you have let's say a scenario, the classic AI scenario, you have one kid in one side and 4 people in another side. Where do you turn? And the computer could come with crazy strategies. I don't know, spinning the car around, or it doesn't. Yeah. It could evolve into such a high grade capacity of control and creating their own strategies that we as human cannot predict. Like Bryn said, we have our, like you said also, we have our bias, we have our limitations. But if you extrapolate 100 years from now, 200, I mean, we are going to be the same, genetically speaking, apart if we're going to do any genetic modification or Neuralink type of changes, but our brains are going to be essentially the same. But these machines, we are talking about maybe 30 years of evolution. There was not even phones, or we are talking about 486 processors. Imagine in another imagine another 30, 40, 50 years. Is like I said, it's just a matter of time. Hopefully my career is already almost over. I'm 36. I have a couple more years that I can race professionally. So I'm super glad that I took the prime out of motorsport. But at one point, it will be much better than the humans. It will be a phase that will complement humans, especially if humans want to have fun. So what is the fun of sitting in a car that drives at itself at the crazy speeds? It would be fun. It would be like a roller coaster. But then complement your driving, maybe there is more to it when you talk about the involvement with humans and the machine. But there will be no limit to what the AI can do. And I'm very curious to know what this future will bring.
Yeah, there was some great research data that's come out from ETH Zurich and Sony AI over in Switzerland, where they use Gran Turismo Sport.
I saw that. It was amazing. Yes.
Yeah. It's like a competition where you had AI drive the car, and it beat 50,000 human drivers. It was awesome. It's incredible. It sits right at the top end of the bell curve, if you like, of performance. So, so just right at the edge, basically. So you'd have to be, let's say, an expert driver executing everything right to the limit all of the time. And then the feedback from their human reference driver was, I couldn't do that. 99, well, I think it was 999 times out of 1,000, I'd end up having a collision. I'd be able to do it once. And that's really the interesting thing. We haven't seen that in the physical domain. And I wouldn't underestimate how difficult it is to take that learning in a simulation environment and put it into the physical domain, where you have so much more noise that humans are very good at dealing with at the moment. But yeah, at the end game, as Lucas is describing, if the AI is so good and it's got like the abundance of confidence that it needs to just drive on the limit all the time and executes it perfectly, it's going to be very hard for humans to beat that. But at that point, it becomes the best trainer that you could ever imagine, because it knows exactly what is possible and what you can do. So if you're looking for future racing stars as they grow up, training with an AI system, they will end up performing better than if they trained alone.
Yes, that's perfect, Bryn. That's exactly on the point. And actually, the last time I drove the car against the computer in this track in France, I could look. I still beat the computer in pretty much every corner, but I started to see for the first time the computer doing something that I could look into the data and improve my own driving. So when you have let's say an AI driver coach, you'll be able to see the maximum what this hardware can do, and then basically saying that I cannot get faster in that corner. You have a reference to say that or not. And now you don't. Now you just have the best driver or your teammate or the data from another day. But with an AI being perfect all the time, will be the perfect trainer. That's a very good analogy from Bryn.
Yeah, Lucas, you go more than a couple laps in anything. I mean, the physical endurance and the physical condition that a human driver has to be in to sustain the number of laps that it takes to win a race is part of it, but we know that there is mind-body coherence, and we also know that as your body fatigues, your chances of making a mistake. I'm a mountain biker, and I understand that the second I start feeling a little too physically taxed, that's when I'm going to take a lazy turn and hit a rock. And I do it all the time. So in your case, it makes a lot of sense what you're saying, that a human driver will feel fatigue. A human driver might get understandably distracted by some kind of vibration, and it only takes you 250 milliseconds to think, what is that? Take your eye off something and not realize that there is actually a much bigger problem that just popped up over here. You're right. The algorithms can, the algorithms will do better 10 times out of 10 because the electronics will not become fatigued. And the
reaction time is so much faster. We have a neurological limit to transmit the processing information from our eyes to our brains and to send the signal back to our muscles and contract them chemically and give the input to the car. That takes about between 200 and 300 milliseconds, while with an electrical systems, we are talking the speed of light is the limitation, physically speaking. And so it's almost incomparable in terms of reaction time. What will be very difficult, and we'll still need to build a bigger database, is the prediction. So, for example, if I'm driving against a driver, I know what the driver will do. I can predict stuff that AI will be only able to predict if he has the same amount of data that I have. So this type of creativity, let's say instinct, what they say, this will be a little bit later for the AI to master. But if you give the system the right data input, if you, let's say, you're going to compete against a driver that I know very well. Let's say I'm going to compete against Lewis Hamilton, and I've raced with Lewis since from younger age, and I really did. We are about the same age, so we're racing go-karts, Formula 3, Formula 2 together, Formula 1 together. So I know how he will behave. I know how he will try to overtake. I know which corner. But you can take all the record images and videos from every single race of Lewis Hamilton from zero to now, feed to an AI, and the AI will predict what he will do, probably better than I do also. So the instinct that I have racing against somebody else also could be transferred to the AI. And you could do that with any driver or with hundreds of drivers, with millions of data points. It's basically infinite. That's why it's very, very hard to compare a general artificial intelligence in a sense with a human. We are limited to our lifespan and our brain capacities, which a cloud of millions of points of data, they are not. So it's just a matter of time until it also gets better also in this domain, which will be later than the reaction, which will be prediction, but it will happen also.
No, I think right. Lucas told me a story once about his experience at Le Mans. So it's an endurance racing in Le Mans, and you have very long stints. And I think, Lucas, you were saying towards the end of the long stints, you can see more variability in the lap time. The performance is still there, but it's the variability as you're passing traffic and the decision making that gets affected the most.
It's almost like, sorry for the ridiculously lame analogy, but it's almost like laying down an engineered wood floor, where if you introduce that much of a gap in one plank, by the end of the room, your gap, if you keep repeating that same error, it's the same thing when you're making, slightly longer decision times, or maybe the words of your coach and your team reminding you that, hey, watch out for this guy, because as you recall, in those final laps, he likes to get really close and kind of edge people out. Maybe those words aren't as loud in your mind and you kind of forget about it for a second. Whereas a machine, obviously it's doing math and executing accordingly. I could talk about this all day. I can hear in my head the CEO of All About Circuits telling me you have to let the audience ask questions. So I think it's time to do that. Let's take a few questions from the All About Circuits community and the participants here. And by the way, if you are watching this and you have the good fortune to be with us live right now, you can submit your questions in the chat widget. We need to invent a better word than widget, but that's what it's called right now. Put it in the chat widget, and we'll do our best to get them answered while we're in this session here. So let me just pull up the first few, and this is from a gentleman, presumably named Rodolfo. I think that's a safe bet. Okay, so this is the kind of the high level question that I think everybody wants to ask. Posed to both of you, how far are we away from having AI-driven cars replacing the current technology we have available, and what does that mean to a racing driver of the future? Meaning the kids who maybe would have started in go-kart racing. What do you think that evolution of the driver looks like?
predicting some anything for the future is very, very tricky and normally tends to be wrong. So I don't want to say, but with precision, but I would say, which is a conservative estimate, but less than 20 years from now, there will be already a full replacement for human drivers in any condition and any situation, or most of the situations, most of the conditions. And the future of motorsport, in my opinion, does not look great. It looks, for me, that motorsport will still exist. But the analogy that I always use is horse racing. Well, everybody needed to ride horses. Horse racing was live on TV, was a huge sport everywhere. There was races everywhere all the time. Now, horse races, they live because of bets, and there is maybe 1 or 2 events, or 3, 4 events worldwide, which are still very good, and still people expend a lot of money in horses. They still like it, but you don't need to know how to ride a horse to go to the supermarket or to live in society anymore. You used to need to ride a horse to go to another town 100 years ago, 130 years ago, but now not anymore. So I think with the driving will be similar. My younger cousins now already, they take longer to take the driving license because, again, it's a liability for them. They cannot drink and go out. They have to buy a car. They have to have a responsibility. So they don't want that. They use mobility as a service. They call it Uber. It's all good. It's common sense between the new guys. There is not that social need of owning a car like we had. At least I was counting the days like a prisoner, to get my driving license to own my own car because I wanted to go out with that girl. And by having your own car and picking her up at home was the freedom status that everybody dreamed of, and it's not the case anymore. So society evolves. The perception of younger generation also changes. We have to have this in mind. We cannot use our own references to say the future will look like this because it was like that in the past. So we need to kind of get this social need. So for me, less people driving means less affection for motorsport. So less fans, which is already kind of showing up in data, that it's more of an older generation. Younger, they're not engaging so much. But it still will exist. Still, if you are the best driver of the world, you'll be able to be professional, make a lot of money. Still, people will put money into that because it will be fun. It is a fun hobby. There's a lot of adrenaline. The cost tendency is to go lower with the electrification. So it will still exist, but not as the way that we see today.
Interesting.
Yeah, I think one of the things Lucas mentioned, if you take the horse racing analogy, the role of the trainer in developing the horse and the passion that they put into that, you're going to see the same for the people developing the AI algorithms. The sort of breeding and training of these algorithms and bringing them to the track is an essential role. And, whenever a horse wins a race, the trainer is one of the people who get recognized, as well as the horse and as well as the jockey. Yeah. And I think, you can kind of look at, if you took a stables analogy of that trainer, you'll see multiple AIs coming out of one place, for sure. And they'll drive different vehicles. I think what we're seeing is at the moment, especially post-COVID, is a shift towards, let's say, mobility, but focused around goods and goods delivery a little bit more so than people, So we're kind of moving towards that a different application, if you like, of the autonomous technology. I think, let's say in the next 10 years, we're going to move a lot further than where we are now. There are deployed services that exist now, but on a city level, or actually smaller than a city level, like a retirement home kind of commune level. They will expand. That's the plan. Start in a limited operational design domain and then expand out as you learn. It will be the same in motorsport. It's a confined operational design domain. I do definitely think, we'll expand out of racetracks and into sort of the rally environments and the sort of more organic environments that are much harder to drive on. That will definitely happen. And I think if you look back at motorsport, I'd say the last 10 years, which Lucas was key in pushing forward, has all been about electrification of the powertrain within motorsport. That's where all the innovation happens. That's where the push for the new technology happened. And a lot of championships now are rolling out electrical technology, but it's all been defined in the last 10 years. This 10 years of innovation is all around AI and robotics technology and how that impacts motorsport in the ways that Lucas and I have described today. So it's going to be, for me, technology-wise, it's going to be the most fascinating era of motorsport. This next 10 years will be amazing.
Yep, this will be an exciting. It's an exciting era to be alive in, because it's this inflection point that we get to witness. Exactly. I think it's cool. So I know that I'm officially on borrowed time now. I've used up too much of your time. Are either of you okay going another, say, 5 minutes to answer 2 more questions?
Yeah, of course.
That's fine. Yeah.
Oh, thank you so much. All right. That's if I were doing my job better, and I'm not a journalist, I'm just an engineer, but if I were doing my job better, we would have finished by now. This is coming from a young woman named Min Lee, and she is in Carroll Stream, Illinois. And she asks this: speaking of looking ahead to the future, she notes that I didn't know this, Lucas, you are a United Nations ambassador for the environment, and you took a race car to the North Pole, to the ice cap, to draw attention to ice melting. And apparently recently there was a study announced that the ice in Greenland is at a point of no return in terms of melting. Winter snow, as I understand it, is no longer able to replace the ice cap that we lose in the summer. As an ambassador on environmental concerns, tell us about that project a little bit, and about the 2016 project, and how do you feel about this recent news? What can communities be doing? Our generation, our kids' generation, what can we be doing to help slow this down?
Yeah, so I'm gonna tell the story about this crazy project that we went to the Arctic with a race car, and then probably say something that I never said before, and maybe I should not say, but anyway, it's past already. So the plan was to go with the Formula E car in 2016 and drive on top of an iceberg, not on the Arctic Circle place that we did do the let's say the challenge. The idea was on an iceberg, and we hired this specialist to look for the best iceberg, because you need to be kind of flat to be able to drive a racing car, and the car needs to be like airlifted by helicopter. And so they chose this specific iceberg, and very big iceberg, like 100 meters by 100 meters, 100 meters by 200 meters, huge piece of flat ice. And this is a stable one. It doesn't break, because if the iceberg breaks, it normally melts to a point that it gets unstable, and then it breaks and goes upside down. And all good. They spent a week on the iceberg flattening the surface for us to do it. So I took the plane, I flew to Iceland, took the plane, a small plane, to a place called Kolosuk, which didn't have basically 400 people. We landed on the runway, and everybody from the plane had backpacks, and I had my suitcase that could roll, and everybody was looking at who's this idiot with this suitcase that rolls. And as soon as we landed, there was nothing. There was this small shed of wood with the plane, and basically gravel all the way to the hotel, and there was no cars. I had to walk. So I had to pick my bag, walk to the hotel. We arrived in the hotel.
We need autonomous bags, by the way.
No, but in this case, in the middle of Greenland with the gravel, you need maybe wheels this big, but it was not. It doesn't really work like that. So anyway, backpack would have been much more efficient. Then I arrived there, and then on the day that we're supposed to drive, at night the iceberg breaks and flips. So if it would have been a few hours later, and we're talking about time frames of years of that iceberg to be on that state, and exactly on that night it broke down and flipped. If we were on top of it, we would have been dead, everybody. So then we decided, said, look, this is crazy. The expert was freaking out, say, I don't do this anymore. This is too dangerous. I cannot And so we were there and we're like, what do we do? And then we flew with a helicopter to a place which was about 40 minutes away. And we had to take the car there. And the pilot of the helicopter was a completely crazy ex-army guy. Said, no, I can take the car there, but I need to do refueling in the middle of it. And I was like, refueling where? There is nothing. Is the Arctic Circle. There is nothing. There was nothing there between the place that we needed to take the car on this place that we found and where the car was near the hotel. And I said, no, I will do it. I will take manually a barrel of kerosene, fly it the night before or the day before or the afternoon before, drop this barrel in the middle of the way with a manual pump, go with the car halfway, drop the car in the middle of nowhere, refuel manually the helicopter, and then take the car to that place. And we were like, what? And because the helicopter could not take the load of the car with a full fuel tank, or there was something around that. Anyway, the helicopter took the car there, then came back to pick us up. We went there, and we had a rifle with us because there was a high probability that a polar bear could appear, and we were in the middle of the Arctic Circle with nothing. The closest village from the place that we did that filming was a 7-hour walk. So if that helicopter had any mechanical problem, if there was too much wind for the helicopter to fly off, we would have to walk through crevices 7 hours to the next village to be able to take a boat or something which was there. So I had my overall and my racing boots when I realized that was the case, and I was already there. So the helicopter took the car there, and we were there waiting, me and Alejandro and the other guys, and they couldn't hear the car because we went first. The car was going to come later, and we could not hear. And then suddenly we hear the helicopter brought the car. We did and it was so rough that the car was breaking down in pieces. The wings, everything was crazy.
Really?
Yeah, because it was super rough. We could not have time to do anything. So the racing cars are not made to go in rough surfaces. But anyway, and they said, look, you have a limit. You can drive only up to this point because over there's a huge crevices. You don't want to go there. And you could hear, and we were there standing on the ice. You could hear the water melting. Actually, it was very impressive. When we were coming with the helicopter, when people say about the polar ice cap, you think about like snow from when you go skiing somewhere. But there was this white that would raise from the ocean level up to where you could not see anymore, of a pure solid block of ice extending for thousands of kilometers, and the block of ice was 3 kilometers thick. So we're talking about thousands of kilometers and 3,000 meters thick block of ice melting. It's not a little bit, it's a lot, and you lose the notion because the sky was white, the block was the ice of the Greenland was white, so you didn't know where the ice finished and the sky started. And then we're there, and when we landed, because we were on the edge, on the downside of the cap, there was rivers and rivers of stream of water melting and coming down. And while you were there, you could hear this noise like of the water underneath us there, and like huge lakes and stuff. It was complete. It really opened my mind of what really is going on when they say like the ice is melting. Before you think ice is melting, okay, the ice is melting from the cup, snow is melting when it goes summer, but it's something which is extraordinary big and really impressive. But anyway, I was there.
It's almost as if like a continent or a mountainside is eroding, but a very important continent and a very important mountainside.
And then I saw and then I went there and I walked. I talked to people. Anyway, I saw it I saw the icebergs for the first time in my life, And after that, I said, look, it makes a lot of sense of what we're doing. But when you talk about electric cars, people, they don't realize, because it's such a long time frame. You say, it's going to be without any ice in 100 years. And then people say, okay, 100 years. I don't know what I'm going to do next season. People doesn't really know. Our brains are not really tuned to work in such a big time frames and such a global, something with such a global impact. So you say, it's not my fault. There's another 8 billion people doing it. I'm not going to do anything also because I don't count in this process. So
right.
the approach I took with UN was something which is much closer to us, which is air pollution. You can argue, like Bryn said in the beginning, you can argue how the electricity is being generated for the electric cars. If it's generated by coal, it's really bad because it's still putting a lot of CO2 to charge the car, so it makes no sense. But one thing you cannot argue is that in the dense city centers, urban areas, there is a huge, each human has a huge intake of pollutants coming mainly, especially outdoor air pollution. So indoor air pollution, people make fires in developing countries to cook and so on. That's the main source of death. But in developed countries, and outdoor air pollutions are cars and trucks, especially trucks and logistics. And now it delivers even more. And so any type of transportation is really, really impacting our health. And it's killing more people than COVID every year for many years. So the attention that we have for this topic is very little compared to the damage. And I did a documentary in India as well to check on that. And 9 out of 10 children that now are born in Delhi, they have already a chronic pulmonary disease because of pollution. In the US, 65% of the hours lost to sickness is somehow related to air pollution, even with the asthma or some other kind of heart or pulmonary disease. I did a little bit of research about this. So I decided to focus on clean air. I said, look, electric cars in the middle of cities, they do low mileage, so there is no range anxiety. They don't pollute. You can say biofuel this, biofuel that, but in the end, if you emit gases where people live, you're breathing them, it's bad for health, has a huge impact on the pocket of the state because you have to take care of people with healthcare, has a huge impact on people's health. So I guess this is much easier to communicate. And that's what I did with UN. So the focus is on clean air, is on electric vehicles on this specific topic.
Brilliant. Good for you. And thank you for your efforts in this, because, nobody will be unaffected by things like this. And, as we get more and more smart cities and we're adopting more of those types of platforms, we are able to collect more and more real data about air quality. And hopefully when that data gets published, a lot more attention can be drawn to it with factual citations in what's being published. And that's it is a very sobering problem to solve. But again, hopefully we are living in a time where we are at an inflection point, and we are engineering cleaner solutions at least. But it begs a follow-up question. You're married. Does your wife ever wonder, like, slow down? It's not enough to be driving 200 miles an hour 3 wide. Now you have to go and fight polar bears and drive through splitting ice and ice rivers and everything else.
Yeah, I appreciate the question, and she didn't know about. Actually, she doesn't know the full story. I think she's probably listening from in the living room there, and I'm gonna get some.
Oh no!
Yeah, but now I have a kid. I have a 2-year-old kid, and I'm actually choosing now where I take my risks, because you cannot just take crazy risks all the time. Of course, as a racing driver, you're already committed to some risks, but I'm trying to be a little bit more, let's say, less crazy on these topics. But it still doesn't compare. Motorsport is very safe. We're just trying to make it safer, and it is a profession that I love, and I'm trying to use it to turn into to use that knowledge and know-how and that network and that public access to turn the world of mobility into a better place. That's what I always wanted to do. And I have great people around me, like Bryn, like Dennis, like Agag, the founder of Formula E and Extreme E. I'm launching now. I launched a month ago an electric micromobility world championship called ESC, so Electric Scooter Championship. We are producing this extremely fast electric scooter. We're going to do a race around the world, a championship, to also promote safety in micromobility, because in the end, it's much more dangerous to ride a scooter in an urban area at 30 kph without a helmet than to drive a race car in a prepared environment, in a prepared way. So it doesn't really matter if we develop all of this with Roborace, and then people are just going crazy with the electric scooter that they hire, and then they race, and then they have traumas. Right. So it's all a lot of work, but for a good cause.
It's great to be in a position where you can be an ambassador, not only for the sport, for the industry, but also for the causes that improve all of our quality of life collectively. Hopefully,
a little bit already will help.
Absolutely. Well, guys, Bryn, is there anything you wanted to add before I'm now getting? I should show you my phone, but I'm getting text after text like, wrap it up. So I better let you guys have your lives back.
It's been really great to talk to you though.
Believe me, the pleasure has been all mine. And I'm sorry, I'm just trying to scroll through these questions really quickly. And I'll just kind of sign us off here. We have a lot of questions. My apologies. Good thing we can edit this. All right. Almost there. Okay. So now I'll just smoothly get us out of this conversation. This has been so much fun. Unfortunately, we are out of time. And, I could not have enjoyed this conversation any more than I have. Lucas, Bryn, thank you so much for joining me. And I have decided that even though you didn't offer, I will take you up, Lucas, on an offer to take me for a few laps around the track the next time.
Next time we're gonna put you yourself in the autonomous car, because it fits in the DevBot. We can put a human there, and the car will drive you around the racetrack at racing speeds.
I love it.
That's the most scary thing you can do at the moment.
Yeah, I'm a control freak, so I love the idea that we're putting my money where your mouth is. I'm totally in for that, and I trust you. I wouldn't do that with anybody else. But
trust Bryn. He's the mastermind behind it.
You're good. You'll be good.
I feel totally safe. No, I'll have my people call your people. And those of you watching this at home or at work, remember, this week, Industry Tech Days, it's your week to take advantage of 50 live sessions with the leaders in our industry. And we start at 9 a.m. Eastern every day. And you can join us live or on demand for all of these sessions throughout the week at allaboutcircuits.com. Hey, thanks, guys.
No problem at all.
Thank you very much.
That was Lucas DeGrassi and Bryn Balcombe from Roborace in a conversation originally recorded on September 2nd, 2020 as a keynote address for Industry Tech Days. In our next episode, we'll talk all about autonomous robotics with Qualcomm's visionary Dev Singh. Thanks for listening.